First off, there are three forms which we usually use to write ratios. The first is to say A to B, or we can use numbers such as 4 to 7. The second way is to use a colon, and we could write A to B that way, or 4:7 that way. That's usually done in gambling or in Vegas or at the horse races. And the third way is to write this as a fraction A to B, or in this case 4/7. We then want to be able to reduce ratios, and I'm going to begin with 18 feet to 40 feet. Notice that these ratios have units attached to them, but we are allowed to cancel out those units just the same way we cancel out numbers when we're simplifying a fraction. We are going to reduce the 18 over 40. Each of them can be divided by 2, so let's do that. Divide by 2 over 2 and get 9 over 20. So 18 feet to 40 feet can be reduced to the ratio 9 over 20, which doesn't even need to have units attached to it. Now let's reduce the ratio $25 to $10. Again, we can cancel out those dollar signs, those units aren't needed, and the 25 and 10 can be reduced because each can be divided by 5. So in this case, we would write this as the ratio 5 to 2. Now, when we are dealing with ratios, we do not convert to mixed numbers, nor do we convert to decimals. We want a ratio of two whole numbers. Now I'd like to reduce the ratio 10.4 to 3.25. Notice that we have decimals this time. What we do when we have decimals of varying lengths is we look at which one has more places after the decimal. And in this case, the denominator has 2 places after the decimal. I'm going to pretend that there's a 0 up in the numerator so that we have an equal number of places in both cases. Now I'm going to multiply the numerator by 100 and the denominator by 100. Notice I'm multiplying by 1 in the form 100 over 100, and that the fraction that we get will be equivalent to the one that we're starting with. Now what we have is 1040 divided by 325 without those decimals, and now we can reduce this the way we're used to. I notice that they're both multiples of 5, so I will begin by dividing by 5. Now I might need to use some scratch paper here over on the right, so 1040 divided by 5. 5 goes into 10 2 times perfectly. Let's subtract that 10. There's nothing left. Bring down a 4. 5 does not go into 4, so I'll put a 0 at the top to say no it doesn't. Then bring down the next 0, and 5 goes into 40 8 times. Now let's do the same thing with 325 divided by 5. 5 goes into 32 6 times, making 30. We subtract and get 2, bring down the 5, and 5 goes into 25 5 times. So now we can see with these quotients here that 1040 over 325 reduces to 208 over 65. Then we have to see whether we can reduce this further. I happen to know that 65 is 5 times 13, and 5 does not go into the numerator, but perhaps 13 does. So let's check. 208 divided by 13. 13 goes into 20 one time, making 13. We then have 7 left, and we bring down the 8. Well, 13 times 6 is 78. So that goes in 16 times on the nose. And so if we are dividing both the numerator by 13 and the denominator by 13, the denominator will be 5 and the numerator will be 16. And 16 over 5 would be our reduced ratio. Now let's reduce a ratio that contains mixed numbers. First off, we will need to convert each of these to improper fractions. The numerator becomes 5 over 2, and the denominator becomes 13 over 4. Well, anytime we divide fractions, we know to multiply by the reciprocal of what we're dividing by. So we will have 5/2 multiplied by 4/13. And I can cancel across the multiplication sign here, dividing both the 2 and the 4 by 2. And remember, you can only cancel across a multiplication sign, not across any other sign. Now multiplying across, I'm going to have 10 over 13, and that does not reduce, so that right there is our reduced ratio. Now let's take a look at a short little application. I won't write the whole problem out, but let's pretend that your class contains 18 men and 22 women. So there are 40 people in the class altogether. We get that 40 by adding 18 and 22 together. When they then ask you to find the ratio of two things, you need to look carefully at what two things are being compared. The first thing will be our numerator of our ratio, and the second portion will be our denominator. I want to find, in this case, the ratio of men to total students. Well, in this case, as I said, the men will go in the numerator, 18, and the total students, we already said, adds up to 40. That will go in the denominator. Now it's time to reduce this ratio. 18 and 40 are both even, so I know that I can divide each by 2. 18 divided by 2 gives me 9, and 40 divided by 2 gives me 20. Now 9 and 20 are relatively prime. That means there is no factor in common that can be divided out, so this is now simplified.